Tutor shown. We are doing baseline assessment 2023. So let's dive in. Question 1 says, given the linear number pattern 21, 18, 15, 12. Okay, 1.1 says, write down the next two terms of the pattern. Okay, a linear pattern or a linear number pattern is same as an arithmetic sequence. So here we can see the difference or the common difference to be, okay, second term minus first term. 18 minus 21 is negative 3. 15 minus 18, negative 3. 12 minus that, negative 3. So we have a common difference of negative 3, right? So 12 plus common difference of negative 3 is 9. 9. So 9 plus negative 3, that's 6. So these are the next two terms, 9 and 6. 1.1, next two terms are 9 and 6. 1.2, that's for 2 marks. So 1.2 also for 2 marks. Determine the expression for the general nth term in the form Tn equals to Dn plus C. Okay, remember the nth term is found by a into n minus 1, common difference. So first term is 21 plus n minus 1, common difference is negative 3. So you have 21, negative 3 times n, that's negative 3n. Negative 3 times negative 1, positive 3. So you have 24 minus 3n. That's your nth term for 2 marks. Okay, 1.3 says, which term of the pattern is equal to negative 6045? Which term is equal to 6045? Okay, so it means you are finding n. We are looking for n. So negative 6045 equals to 24 minus 3n. Okay. Divide both sides by negative 3. Remember, n always has to be positive and it has to be a whole number. So 6069 divided by 3, 2023. Okay, 2023, that's your n. Okay, moving on to question 2. Question 2 says, consider the quadratic number pattern. Question 2, consider the number pattern 5, 40, 27, 44, and it goes on and on. Now 2.1 says determine the general term in the form Tn equals to an squared plus bn plus c. Right. It's a quadratic number pattern. Okay. If it's a quadratic number pattern, remember you have first difference and second difference. So your common difference is in the second difference row. 14 minus 5 is 9. 27 minus 14, that's 13. 44 minus 27, that's 17. Okay. 13 minus 9, that's 4. 17 minus that, that's 4. So this is your common difference. Right. That's your common difference. Okay, what are the conditions for quadratic number patterns? No? Remember, 2a is second difference. 3a plus b is t2 minus t1, right? Also, a plus b plus c is your t1. Right. Here, what are we required to find? We are required to find the general nth term. General nth term, meaning we need the values of a, b, and c. A, b, and c. Okay. Let's say that's 1, 2, 3. So from condition number 1, we can find a. 2a is d2, which is your 4. A is 4 by 2, which is 2. Right? So after finding a, we can find b. Right? 3a plus b equals to t2 minus t1. So 3 into 2 plus b is t2 minus t1 equals to 9, right? Which is 14 minus 5. So 6 plus b equals to 9. So b is 9 minus 6, which is 3. Okay. Now, what do we need? Value of c. We need value of c. Okay, from the equation, a plus b plus c equals to t1. From this equation, we can say a was found to be 2. So 2 plus 3 plus c is t1 is 5. So 5 plus c equals to 5. C equals to 5 minus 5, which is 0. So our nth term is given by 2n squared plus 3n plus 0, right? plus 0. You don't have to write plus 0. Okay, that's plus 0. And that's your final answer. Okay. Moving on, we go to 2.2. 2.2 says calculate T50, the 50th term of the quadratic pattern. The 50th term, T50. So we know that Tn is 2n squared plus 3n, right? So T50 is 2 into 50 squared plus 3 into 50. How much is that? Okay, 5,150. So 50th term is 5,150. Okay, we are moving on to 2.3. Okay, 2.2 was worth 2 marks. Okay, we're moving on to 2.3. 2.3 says determine the general term for the first differences of the quadratic pattern in the form tk equals to dk plus p. Okay guys, the question says determine the general term for the first differences. First differences are d1, right, which are 9, 13, 17, right, and so on and so forth. So they say determine general term for the first differences, as if this was your pattern. Actually, they want you to consider this the pattern and determine the general term for this pattern. Okay. But now, if you consider this pattern as the original pattern or a pattern to consider, then this is no longer quadratic. This is no longer quadratic, therefore the nth term or the kth term as they represent it by k, right, will be a plus k minus 1 and your difference of p. Your difference is represented by p. Okay, so the first term is 9. The first term is 9 plus k minus 1, and the difference, their difference is 4, right? K times 4 is 4k, minus 1 times 4 is minus 4. So tk equals to 9 minus 4, that's 5, plus 4k, plus 4k. Okay, tk is 4k plus 5. in the form that they wanted. And this is 3 marks. Okay. 2.4 says, hence or otherwise, evaluate the first difference between T100 and T101 of the quadratic pattern. Okay, the first difference. All right. Okay, 2.4, they say, evaluate the difference between T100 and T101, right, of the quadratic pattern. So, of the quadratic pattern, we found the nth term to be 2n squared plus 3n, right? So, T101 is 2 into 101 squared plus 3n, right? And T100 now what is T101? Okay, T101 is 20705 and T100 is 2300. So T101 minus T100 is 20705 minus 20300, which gives us 405. Okay, we are moving on to question 3. Okay, matriculants, still on question 3. Question 3 says the graph of f at x, which equals to a into x minus 1 all squared plus 8 is sketched below. Okay, let me just show you the diagram, but then guys, you should download the question paper now. Download the question paper. Okay, this is the graph. Okay, question 3.1.1 says, write down the coordinates of E, the x-intercept of F. Coordinates of E, I can just look at the diagram and write them down. And they are 3 and 0. Okay. How did I find them to be 3 and 0? You might ask. Look at your diagram now. Look at your diagram. This is a rough sketch, a freehand sketch. So you have your point A here, which is -1 and 0, right? Here you have your C, the turning point. Here there is point D, which is 2 and 6. This is point B, and this is the graph of F, O, and point E. Right? So from the equation, okay, this is your turning point of the graph, and from the equation we can see that the turning point is 1 and 8, right? From the equation, remember the equation in its original form says f at x is a into x minus p. It can be squared. Okay, according to this one, it is squared plus q. Now, p and q are the coordinates of the turning point. And this is the standard formula. So from this equation, I'm saying the coordinates of the turning point are +1 and +8. And remember this one. X minus x1, x minus x2. Okay, this is for x-intercepts, where your y is equal to 0. Your x1 and x2 are the x-intercepts. Okay. From this formula, we can see that our x1, x-intercept at point A is -1, right? And remember, this line here, this broken line that I just drew, is the line of symmetry, meaning whatever distance you have from here up until point A here is same as the distance from here to point E. So from the line of symmetry to point A is how many units? It's 2 units. How do I know that it's 2 units? A is at -1, at x is -1, and our line of symmetry is at x equals to +1. So from -1 to +1, that's 2 units. Now count 2 units from line of symmetry to point E, and you will have your coordinates for point E. So this is +1, so plus 2 units, that's 3, right? So this is at 3 and 0. Okay, let's move on. Remember, if you are not following well, you can always send me follow-up questions and I will help. You can also send me the questions via WhatsApp. So let's move on to question 3.1.2. Okay. One-on-one tutoring for grade 12s is 40 rands per hour. 40 rands per hour. One-on-one sessions. Okay, 3.1.2, they say write down the coordinates of C, the turning point of F. We already did that. From this equation, the turning points are +1 and +8. 3.1.3, the range of F. The range of F. Okay, looking at the diagram, we can see that the turning point is at y equals to 8, right? And from that, the graph continues downwards, right? The graph continues downwards. Therefore, our y is less than 8, less than or equal to 8. any real numbers less than or equal to 8. Okay, that's our range. 3.2 says calculate the value of A. The value of A so we can find the value of A using a point on the graph. We are told that f at x equals to A into x minus 1 all squared plus 8. Now, there is a point on the graph, point D, which is 2 and 6. So, we'll substitute that point in the equation to find the value of A. So, 6 equals to A into 2 minus 1 squared plus 8. So 6 equals to A into 1 squared, which is 1, which is 8 times 1 is 1 anyway, so plus 8. So A is 6 minus 8, which is negative 2. Hence, the graph is concave down. The value of A is, if the value of A is negative, your graph is concave down. It is facing downwards, or it continues downwards. If your A was positive, your graph would be facing upwards or continuing upwards. Okay, let's go to question 3.3, which says for which values of x is f at x less than 0. For which values of x is f at x less than or equal to 0. Okay, but we know that from the sketch f at x equals to 0 at the x-intercepts. At the x-intercepts, f at x equals to 0 and f at x is less than 0 as x goes to the left from this point going to the left, also from this point going to the right. So f at x, for which values of x is f at x equal or less than 0. So the first one, x is equal or less than negative 1 and x is equal or greater than 3. See? So negative 1, positive 3. Okay, moving on to question 4. Question 4 says given h at x equals to 2 over x plus 3 minus 1 minus 1. Okay, here we are required to write down the equations of the asymptotes of h. equations of asymptotes, that's 4.1. So when they ask about the equations of asymptotes, they merely want the x and y values that the graph did not touch. If you remember, the standard form is a over x minus p plus q. That's the standard form. So the asymptote x is -3, y is -1, right? Okay. Meaning this simply means your graph will not touch a line of symmetry passing through x equals to -3 and y equals to -1. There's two lines of symmetry, and those lines of symmetry will intersect at -3 and -1. 4.2, calculate the x and y intercept of h. X and y intercept of h. Okay, so to find y-intercept, you say you first start by equating your x to 0. When you equate your x to 0, you remain with y equaling to 2 over 0 plus 3 minus 1. This is 2 over 3 minus 1. This is divided by 3, 2 minus 3. This is -1 over 3. So that's your y-intercept. And for x-intercept, so here coordinates are 0 and -1 over 3. For x-intercept, you equate your y to 0. So 0 equals to 2 over x plus 3 minus 1. So therefore, +1 equals to 2 over x plus 3. Multiply both sides by x plus 3, or do your cross multiplication, and your next step will be x plus 3 equals to 2. X plus 3 equals to 2. Yeah, you can do your cross multiplication there, and your x therefore equals to 2 minus 3, which is -1. So -1 and 0. Okay, moving on to question 4.3. 4.3 says, draw a neat sketch of the graph of h. Clearly show all intercepts with axes and asymptotes. Okay, I'm gonna draw my diagram here. Okay, I'm just gonna draw it here. I hope it's gonna be neat. Okay. Okay, what do I have here? They say clearly show all intercepts with axis. All intercepts with axis. So okay, I'm gonna say this is 1. Okay, that's 1, 2, 1, 2, minus 1, minus 2, minus 1, minus 2. Okay. My asymptotes, x is minus 3. Oh my goodness. Okay. Okay. Okay, I'll say minus 1, minus 2, minus 3, minus 4, minus 1, 2, 3, 4, 1, 2, 3, and 4. Okay. Now, my asymptotes x is minus 3, right? This is my line, x is minus 3. And y is negative 1. These are my asymptotes. Okay, we are continuing with question 4.3. Okay, this is 4.3, which says draw a neat sketch of the graph of h. Clearly show all intercepts with axis and asymptotes. Okay, those are my asymptotes. This one is y is negative 1, as we found them here, right? Here they are, my asymptotes, and here x is negative 3. You see? Right. Now, the intercepts. My y-intercept is 0 and negative 1 over 3, right? Negative 1 over 3, that is somewhere here. And negative 1 and 0, that is here. Right. Now, you can even go further to find a point where your x is negative 2 if you want to. Okay, here, this is a rough sketch of the graph. Okay, that's it. And the image will be this side. All right. Okay. Now, let's say you wanted to find a point here where x is -2, right? If x was -2, your y value would be -3 squared here is 9. 9, my a value. What is the value of a? Okay, I don't know a. Where's a? I'm on question 4. I'm here. We are here. We are here. Question 4. So if x is -2, you would have 0 divided by 1, which is 1. 1. Okay. And here your point is 1, 2, and 1. -2 and +1. Right. This point. Okay, let's move on. Let's move on. Question 4.4. Question 4.4. Question 4.4 says if x plus y equals to c is an equation of the axis of symmetry of H, calculate the value of c. Okay, here making y subject of the formula, you have y is minus x plus c. So you can see that the gradient is negative, right? If the gradient is negative, this means your line of symmetry is like that. Okay, I'm gonna draw it with a pencil. That's your line of symmetry. All right. Remember, always your line of symmetry passes through your point of intersection where your lines of symmetry intercept. All right. So we know the values here. I mean the coordinates here. They are -3 and -1. These are the asymptotes, right? These are the asymptotes. So you're gonna substitute them here to get the value of c. Okay, our gradient is -1 according to this formula here. Our gradient is -1. So substituting -3 and -1 into this formula, we get -1 equaling to -1, which is the gradient. Now our x value is -3 plus c. So -1 equals to +3 plus c. -1 minus 3 is our c. So -4 is our c. Right? Meaning if our x is 0, your y will be -4. So your line of symmetry passes through this point here. So now I'm gonna draw my line of symmetry with a pen, because now I have 2 points that I am sure of. Right? I have 2 points that I am sure of. So this is my line of symmetry with a pen. Alright, this is y equals to minus x plus c. Okay, can you also see that my line of symmetry passes through point -4 and 0? Okay, we are done for question 4. Let's move on to question 5. Question 5 says below is the sketch of g at x. Okay. And now on question 6.2. 6.2 says sine of 90 degrees plus theta all divided by cos of theta minus 180 degrees plus 3 cos 540 degrees plus theta, right? Okay, what is the first step? Co-ratio of sine of 90 degrees plus theta is positive cos theta, right? It's a co-ratio. Okay, here this is a negative angle. Remember the negative angles. Cos of theta minus 180 is negative cos theta. Negative cos theta, right? Plus, okay, cos of 540 degrees plus theta. So yeah, that's positive cos theta. Positive cos theta. So this is 3 cos of theta. Okay. Okay, the numerator is a co-ratio. Sine of 90 plus theta changes to its co-ratio, which is cos of theta, and it is positive. So from negative angles, looking now at the denominator, from negative angles we know that cos of theta minus 180 degrees is that. Okay, this is 3 cos theta. Since, well, this angle is greater than 360, so it becomes a positive cos theta. Okay, this is same as cos theta divided by 2 cos of theta, which is 1/2. Danko.